Question says 3 capacitors of capacitances 2 microfarad, 4 microfarad, and 8 microfarad are connected in parallel, and a potential difference of 6 volts is maintained across each capacitor. The total energy stored is. So, do I need to sketch it? It's good to always sketch so that it's good to always set a sketch so that you will not make mistakes. You see the actual picture of the problem. Sorry. So they are connected in parallel. This is parallel connection when they share the same terminal. So here they said it's applied what 6 volts. So the first one here is 2 microfarad, 4 microfarad, and 8 microfarad. Now they say we should calculate the energy. Should calculate what they say. The total energy stored. That means the total energy in the system. So, and we know that energy in a capacitor is given by energy W, represented by letter W, equals to a half of the charge times voltage. But in this case, there is no value for charge here. So the parameters we have here are capacitances and voltage. So if you derive this charge here, you know that capacitance equals to charge divided by voltage. So that charge is equals to what? Capacitance times voltage. So if you carry Q equals to CV and substitute in the place of Q here, you have 1/2 of what? C times V times another V, which is 1/2, or you say a half of CV squared. Okay, so in this particular formula that will give us what we want, where C here means the total capacitance of the system. So now, if you substitute, now total capacitance, how do we get total capacitance? Since it is a parallel connection, the total capacitance is simply the sum of the capacitances. So you add the first one plus the second one plus the third one. So equivalent capacitance C equals to what? 2 plus 4 plus 8 to give you 2 plus this 12, 13, 14. That will give you 14 microfarad. So you substitute here. So this will be 1/2 times the total capacitance, which is 14 microfarad. Micro means 10 raised to the power of -6. Then times V squared, which is the voltage. The voltage across them is 6. Remember, this is a parallel connection, so the voltage across each branch in that connection will be the same. 6 raised to the power of 2. So 2 will cancel 14 here 7 times. So you now have 7 times 6 raised to the power of 2 is 36. 7 times 36 times 10 raised to the power of -6. So if you do this multiplication, 7 times 36 will give you 252 times 10 raised to the power of -6 joules. So you check the option. From the option there, the answer is expressed in standard form. Our answer is not in standard form. So we have to convert it to standard form. So from here, the decimal point in this first number is actually here. So convert it to standard form, you have to take the decimal points to the nearest first value. or the nearest, the highest value, like you meet from here, 1, 2, 2 places. So this is the same thing as 2.52. Now, this 2.52 is like 2.52 times 10 raised to power of positive 2 times another 10 raised to power of negative 6. You understand? Because if you do 2.52 times 10 raised to power of 2, it will take you back to 257. So what we mean is, when you move the decimal point towards the left, you increase the positivity of the power of 10 that you multiply with it. So according to law of indices, 10 raised power 2 times 10 raised power minus 6 will be 10 raised power of 10 raised to power of minus 4. So your final answer will be 2.52 times 10 raised to power of what? Minus 4 joules. Minus 4 joules. So our option is option A. So that is how to do this. Don't forget to subscribe, and then for online classes, you can join my WhatsApp group and book a session with me or with my other tutors. Thank you.